All right, good morning. So we are working on now 1.2, which is planning parks, shapes on coordinates grid. This is getting us more with our muscle memory with how to create triangles on the coordinate plane, which will help us really unpack the Pythagorean theorem. But today this is a big tie-in to what we did in the last unit with perpendicular lines. Remember the slopes of perpendicular lines. The slopes of perpendicular lines are reciprocal opposites. We spent a lot of time going through this for a reason. So if it's two, then it's parallel. Perpendicular intersection is -1/2. If it's 3/2, then its parallel slope is going to be -2/3, so on and so forth. Okay. That's how this works, and this plays a big role in today because we know all perpendicular intersections have a 90-degree angle. First things first, we got two different things here. We got similar but different because one's a square, one's a rectangle. Square, we know all sides are the exact same length, and rectangle, we know that there are two lengths that are the same on those ones. So let's do A and B first. So the first thing I'm going to do when I'm looking at this, to figure out exactly what I'm going to do to figure out the other coordinates that go with this, I'm going to first find my slope from A to B. So from A to B, because we don't care about the line intercept, we're just like analyzing slope because that's all that matters for perpendicular lines. The slope from A to B, your M from A to B is, well, it's positive and it goes up 1, 2, 3, right, 1. So your slope is 3. So that means our perpendicular slope has to be the reciprocal opposite of this, which is going to be -1/3. So to make a square, literally, on the coordinate plane when you have an angle like this, to make sure that these are perfect, I'm going to go from this point, I'm going to follow this slope from that point, so up 1, left 1, 2, 3, there's that. Doesn't that resemble a 90-degree angle? You'll see. And go to this point, and also do the same thing, go up 1, and go left, 1, 2, 3, right? 1, 2, 3, right here. Look at that. On my cruddy drawing, I can clearly see that this resembles a square because I got 4 90-degree angles and I got 4 equal side lengths. So what are the other vertices? The other coordinates that match this? Well, I got -1, 2, 3, 4, 5. -5, and that's up to +2. And also my other vertex is going to be at -4. -4, +1, 2, 3, 4, 5. Okay? So there's that. Now the next question, that's how you figured those out. Okay? The next one says find another two coordinates with G and H down there that forms a rectangle. Now, I'm doing 2 examples in one for you guys so you can hopefully make the connections. Again, you're just looking at what's the slope from G to H. And then we're going to take that, and that's up 1, and that's right 1, 2. So your slope of GH is 1/2. Sorry for the messy drawing there. +1 up, +2 to the right. So that means that my slope of my reciprocal line is going to be the opposite, reciprocal opposite. It's going to be -2. Now here's how we do this. I'll do this in a different color so that we can see this clearly in case I overlap in the other one. That's a bad one. I got these markers are the worst. There we go. You should be able to see that hopefully. So check it out. Up 2, 1, 2, left 1. Now if I stop there, I'm not going to make I want to keep going just so I can elaborate on this. Because look, if I go right here, this might resemble a rectangle, but I want to be certain. I do the same thing. I go up 1, 2, and I go left 1. Now my drawing is not to scale, and this might produce what looks like a square. So that's why we're making a rectangle. Follow that same slope again, just so you make sure that it's extra long. So again, go up 1, 2, and now go left 1. So this looks a lot more like a rectangle. From this same point up 1, 2. Is this right? This was up 1, 2, that's right here, up left 1, up 1, 2, left 1. That clearly resembles a rectangle, okay? I guess I could have used my black marker. Why don't I just go back, trace over that with black just in case. So you can see that. That's clearly a rectangle. So the only thing different on rectangles is make sure you follow that slope twice. Remember, I went up 1, 2, left 1, up 1, 2, left 1. That got that line extra long, so it resembles a rectangle. Same with this 1, 2, left 1, 1, 2, left 1. Boom, that's definitely a rectangle. What are your other two vertices to make this? And now, just so you know, I could have gone down the other way if I wanted to, but I just chose to go this way. One vertex is going to be 0, 2. The other one's going to be, looks like that's at 2, 3. Okay, as simple as that. Now, the last one I made to do them on both because I want you to see how easy this is. A vertice to make a right triangle. This one says find another coordinate, spelled that wrong, with both A and B and G and H that forms a right triangle. Well, this reinforced what we did yesterday. So just go down right here straight. So there is my right triangle. This is just reinforcement we did yesterday so we can calculate distance, all right? So that vertice for A and B is going to be over at -1, 1. All right, and that makes a positive. I could have also gone right up here to this guy right here if I wanted to. Okay, I could have done this if I wanted to. Doesn't make a difference how you see it. All right, nonetheless, same thing with GH. I'm going to make this real simple and clear. Put it right there. There's my right triangle. Boom. My vertice for GH is going to be positive 1, 2, 3, 4, positive 4, -2. Done. It's as simple as that. I'll be back in 1 second with one more example. All right, last but not least, just a little bit of review from what you guys did yesterday. Just going over some stuff that might be a little more challenging. I'll do 3 quick examples. We know the A and the B are always the legs. So I got an example here. I know that for this one I'm solving for the C because I know this is the leg, even though it's a bad drawing. I identified this as the 90-degree angle. Well, whatever. It is what it is. So there's my A and my B. So 12 squared plus 3 squared equals x squared. So now we're doing 144 plus 9 equals x squared. And then I got 153 is equal to x squared. Remember, I'm doing all of this to now take the inverse operation of squaring it, which is the square root of 153. So 153 square root of is 12.4. 12.4 equals x. That's the length, and that's the hypotenuse, and that is the longest length. Therefore, we know that works out. Over here, on this one, I do not know either the A or B because that's attached to my leg. So let's just call that the A. So I can call that x squared or A squared plus 15 squared equals 18 squared. So x squared plus 225 equals, what the heck is 18 squared? 18 squared is 324. Now remember, we're not done yet. I got to bring this guy over here because the goal is to get x squared all by itself. So now I got x squared equals, take that a 4, it's an 11, so 324 minus 225 is 99. Okay. Last but not least, I did that wrong, that's 101. No, it's 99. Yes, duh, 99. Last but not least, I square root both sides. I square root both sides, so x equals square root of 99 is going to be 10.9 on the dot. Right there whoopsies. Mental math error. I know it cannot be more than 10 because square root of 100 is 10, so this makes it 9.9. My apologies. Long day today. All right. Last but not least, a little more challenging one. I want to know what this height of this triangle is. So just use your imagination. If this whole length is 20, this right here is clearly 10. Okay, so now I got 10 squared plus x squared equals 13 squared. I got 100 plus x squared equals 169. I subtract 100 to get x squared all by itself, and I get x squared equals 69. I take the square root of both sides, and the square root of 69 is 8.3. X equals 8.3. Why is this important? Because in a future question, I might give you this right here and say, find the area of this triangle. And you know the area of a triangle is half times base times the heights. Right there with that tricky geometry stuff we're doing later. I will see you all tomorrow, or today if you watch the show today.